Good day everyone. We are here to present our topic on radio wave propagation. My name is Clarus Esteban Ignatius. Together with me are Muhammad Firdaus Zamzuri, Muhammad Faris bin Jusli, Muhammad Azam bin Raimi, and Muhammad Saiful bin Sarizan. Let's begin.
Radio waves are a type of electromagnetic wave that have the longest wavelength and the lowest frequency within the electromagnetic spectrum. They are produced by the movement of charged particles, such as electrons, which create oscillating electric and magnetic field that can travel through space. Radio waves can propagate through different environments, including a vacuum, air, and various materials, without requiring a physical medium. Their propagation depends on the type of medium they pass through. In free space, radio waves travel at the speed of light, while in materials such as glass, water, or concrete, their speed and signal strength may decrease due to absorption or scattering. Obstacles can also cause reflection, and diffraction, which affect the signal transmission. Due to their ability to travel long distance and carry information, radio waves are widely used in communication system, broadcasting, mobile network, satellite communication, and wireless devices. The study of radio wave propagation focuses on how these waves travel and interact with obstacles and behave in different environments. Understanding radio wave propagation is important for improving the performance and reliability of wireless communication system.
Now, how it functions. Radio wave transmit information by converting data into electromagnetic radiation at a transmitter, which then travels through air to a receiver. We realize this daily on Wi-Fi, mobile networks, and satellite communication. However, in real-world engineering, this propagation is deeply affected by distances, obstacle, and atmospheric condition. Understanding these variables allows us to optimize frequencies and build more reliable wireless system. That's all from me. I will pass to the next presenter.
The wave function that must be used to solve this question can be stated as the E. E equal to electric field times with the sign bracket of kx minus with omega t, where k is referring to the wave number and omega is referring to the angular frequency, and the unit of angular frequency is in radian per second. So the second step is the question asking for the amplitude, wave number, and also the angular frequency. So from this wave function, we know that the amplitude in this case is the 50 volts per meter, because for electromagnetic waves we usually use the unit of volts per meter instead of unit in meter, because unit in meter is usually used for mechanical waves. And the wave number can be known as k. So from this wave function, the wave number is equal to 2 pi, and the angular frequency is 4 pi exponent of a radian per second. Radian per second is the unit for angular frequency, and for the wavelength can be calculated by using the wave number formula, which can be stated by 2 pi divided by lambda. So we just have to manipulate the mathematical formula. So lambda is equal to 2 pi divided by k. Since k is 2 pi, so 2 pi divided by 2 pi, it equal to 1 meter. So the wavelength is equal to 1 meter. And for the frequency, it can be calculated by using the formula of 2 pi f is equal to omega. So we just have to manipulate the mathematical formula. So f is equal to omega divided by 2 pi. The omega is known as 4 pi exponent of 8. So 4 pi exponent of 8 divided by 2 pi, we will get the answer of 2.0 exponent of 8 hertz, or also can be written as per second, because it's also the unit of frequency. And the last one, we have to calculate for the velocity of the electromagnetic waves or these radio waves. So we have to use the wave relationship formula where V is equal to F lambda. So we know that F is 2.0 exponent of A and the lambda or the wavelength is 1. So we just have to plug in all this information into the wave relation formula. At the end we get the answer of 2.0 exponent of meter per second. Meter per second is the unit for the velocity of an object or the electromagnetic wave. In this case is the radio wave. Same goes to question number 2 and question number 3. But for question number 2 and question number 3, the information is different. So, but the method is all the same.
Real world implementation of radio waves. The first one is radio and television broadcasting. Radio waves are used to transmit audio and video signals from broadcasting station to receivers. The transmitter converts information into electromagnetic signal which travel through the atmosphere and received by radio or television. This allows people to access news, entertainment, and educational content over long distance. Second one is mobile communication network. Mobile phone use radio wave to communicate with nearby cellular towers. Radio waves carry phone, voice calls, text messages, and internet data between devices and network station. Different frequency bands are used to provide reliable communication and wider coverage. Third one is Wi-Fi and wireless devices. Wi-Fi system use radio waves to provide wireless internet connection between devices and routers. These waves allow computers, smartphones, and smart devices to exchange data without requiring physical cables, making them modern digital communication more convenient. Last part is satellite communication and GPS. Satellites use radio waves to transmit and retrieve signals between Earth station and satellites in space. This technology supports GPS navigation, weather monitoring, television broadcast, and global communication by enabling information transfer across very large distance. Next part is potential benefits from radio waves in the real world. The first one is global communication. Radio waves enable wireless communication across long distance, allowing people to connect through mobile networks, radio broadcasting, television, and satellite communication. Second one, faster wireless connectivity. Radio waves provide wireless data transmission for technologies such as Wi-Fi, Bluetooth, and 5G networks that improving access to information and digital services. Third one is navigation and location service. Radio waves are essential in GPS technology, allow accurate positioning and navigation for transportation, aviation, and maritime system. Fourth one is emergency and safety application. Radio waves support emergency communication system used by rescue team, aviation, and disaster response organization to exchange critical information during emergencies. Last part is support for technological innovation. The use of radio waves contribute to the development of smart device, Internet of Things, healthcare monitoring system, and future wireless technologies.
Now we're talking about challenges of radio waves in real-world applications. The first one is signal interference. Radio waves can be disrupted by other electronic devices, communication system, or overlapping frequencies. This interference can reduce signal quality and affect communication reliability. The second one is signal attenuation and obstacles. The strength of radio waves decrease as they travel over long distance. Buildings, mountains, and other physical barriers can weaken or block signal, reducing the coverage. The third one is limited frequency spectrum. The available radio frequency spectrum is limited. The increasing number of wireless devices creates congestion and requires effective frequency management. And the last one is security and privacy risk. Since radio waves travel through open spaces, wireless signals can potentially be intercepted. Strong security measures such as encryption are required to protect transmitted data. Now we move forward to future development and new innovation of radio waves. Future development in radio waves technology focus on improving communication speed, signal reliability, and energy efficiency. Researchers continue to develop advanced wireless systems that can provide better coverage and higher data transmission rates. The first one is advanced 5G and 6G networks. Future wireless networks such as 6G aim to deliver faster communication speed, lower latency, and support more connected devices for applications like smart cities and autonomous systems. The second one, the improved signal processing technology. New techniques such as artificial intelligence (AI) and advanced antennas are being developed to reduce interference, improve signal quality, and optimize radio wave transmission. The third one is better satellite communication. Next generation satellite will enhance global connectivity by providing faster and more reliable communication, especially in remote areas with limited network access. The last one is integration with smart technologies. Radio waves will continue to support the growth of Internet of Things, IoT, smart devices, healthcare monitoring, and automated systems by enabling efficient wireless communication.
Radio waves are an essential part of modern technology, enabling wireless communication and information transfer across the world. The ability to travel through different environments allows them to be applied in various fields such as broadcasting, mobile communication, satellite system, and navigation technologies. Although challenges such as signal interference, limited frequency availability, and security risks exist, continuous research and innovation continue to improve the radio wave technologies. Future development in advanced wireless network, satellite communication, and smart technologies will further enhance the efficiency and reliability of radio wave application. Overall, radio waves play a significant role in connecting people, improving the technological system, and supporting the development of future communication solutions.